Mr. Sam's, it is freezing out here.
I know, the kids got a snow day and we had to come in today.
Oh, look at this snow. I'm so cold. Oh, my God.
I think there's pretty good chemistry solution to being cold.
Oh, I know about that. What if we were to, like, burn something?
We could.
And maybe I could warm my freezing hands. They're, like, turning blue.
Exactly. Let's do some combustion reactions.
You know, I happen to have brought something with me, actually.
Did you? Oh, really?
Yeah, I have.
Like a flammable liquid.
A flammable liquid.
Perfect.
I brought a flammable liquid. Happens to be, by the way, ethyl alcohol.
Nice.
So.
Well, it just so happens that I brought a fire starter.
Wow.
So this is even better.
You are amazing, Mr.
I know.
Sam's.
I just happen to have it on me.
So I think we should take that ethanol and light it on fire.
I think you're right.
Okay, so.
There it goes, and we can't see the flame. There is the flame.
I can see the flame. We could probably zoom in on the flame. And boy, oh man, now
That's
I'm
nice.
That is very nice.
Yeah.
We are burning ethyl alcohol,
Yeah.
ethanol. And we're going to learn how to write that appropriate equation in just a little bit.
Yeah, this unit we're talking about chemical reactions, and combustion reactions is one of them that we're going to do, and this is one of our favorite reactions to demonstrate.
Yes,
and it keeps us nice and toasty warm.
Nice and toasty warm. Mr. Sam's?
Yeah?
What are you doing?
What do you mean?
Mr. Sam's, we're in my classroom. I'm warm now.
My coffee got cold. I got to warm it up.
Mr. Sam's?
Yes?
You're scaring me.
But my coffee's cold.
You don't even have your safety glasses on.
I have my glasses on.
It's true, you do. Hey, it's now warm, Mr. Sam's.
Much better.
Much warmer. So, hey, I think we should learn how to write formula equations.
Let's do it.
Okay.
All right.
So, podcast 4.1, we're starting unit on reactions.
Yeah, now guys, if you did your work in Unit 2 and you learned how to write the formulas from names of compounds, this is going to be really, really easy.
Yep, it's going to be easy. Okay, good. Hey guys, before we start, something I want you all to do, and that is, I forgot to add a marker there. I want you to tape a couple of tables into the back of your composition book. So if you go to the back of your composition book, you'll find these two tables. The first table is this table right here. It's called the activity series of the metals.
And these are in your packet.
They're in your packet. So I don't know what page it is. That's going to vary from year to year. You're going to cut this table out, put it in your packet. Okay, put it in your packet, or no, put it in your composition book, and we will use it later on. The second table is the table of solubilities. I want you to take this table and cut it out. We'll use it later. I just want to kind of prep us for this, okay? So just a quick little side note. All right. Word and chemical equations.
Yeah.
You know, before we start, Mr. Sam's, we got to talk about one thing.
Okay.
That I realized that I didn't put in the slideshow.
We're wearing matching shirts.
Yeah.
Is that the one thing?
That's not matching.
Oh.
Close.
Okay.
They both happen to be red. But I want to talk about the elements that are always diatomic.
Oh, yeah.
So everybody write down diatomic elements. What does that mean, Mr. Sanders?
Di, that means two. Atoms.
Two atoms.
Yeah.
So there are several atoms that when you see them by themselves, they are written with a 2. What would those be, Mr. Sanders?
I call these the Brinkelhoff elements.
The Brinkelhoff. Okay,
Yep.
what? Brinkelhoff.
Yeah,
that sounds like a German name. Brinkelhoff.
Br.
Br. Okay, I can do that. Br.
I.
I.
N.
N.
Cl.
Cl.
H.
H.
O.
O.
F.
F.
Brinkelhoff.
Brinkelhoff. Nice.
Yeah. So that's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Those 7 elements are always show up in pairs. So if you have just bromine, not bromine in a compound, not bromide, just plain old bromine, it's Br2. Plain old iodine, it's I2. Plain old nitrogen, N2. Plain old chlorine, Cl2. Plain old hydrogen, H2. Plain old oxygen, O2. And plain old fluorine, F2.
Another way to do this, guys, that would help you understand this is to look at a periodic table, Mr. Sams.
Yeah.
What you have is here we have periodic table. There's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine.
That looks kind of like a number 7.
So if you kind of put a box around that, that looks like a 7.
Yeah.
And there are 1, 2, 3, 4, 5, 6. And actually there's a 7th one, and that's hydrogen. So I sometimes call these the magic 7 elements.
Yeah.
You know, whatever works for you to understand this. If you like Mr. Brinkelhoff or the Magic 7, it makes no difference. You just need to understand that whenever you see oxygen by itself or nitrogen, then it's N2 or O2
and
or
the
F2
key there
or
is that
whatever.
it's by itself, not in a compound.
Right. So what would be an example, Mr. Sams, when it would not be by itself?
Well,
that would
let's look at
illustrate
the reaction that we just did outside. We had ethanol.
Okay. So actually, let's talk about this here.
Okay.
Actually, before we do that, we'll do this here. Yeah, we'll get there. We'll do that in a second.
Okay.
Because I think we've got some rules.
Oh, yeah, you're right.
What is a word equation?
That's a chemical equation written in words. It says so right there on the
Yeah,
screen.
well, good. So
Yeah.
you want to write that down for your notes. Okay, that's what we have it written in words. But scientists, chemists, we don't like
we don't
words.
like words.
We like symbols.
Yep, symbols, numbers.
Yeah. Okay. So a chemical equation is a chemical equation written with formulas. And so we want to write them with formulas. And so the reason we talked about this Brinkelhoff thing is that we want to teach you how to write them in formulas. Okay?
All right.
So let's say, how about we do this example that we did outside?
Alrighty.
So here we have ethanol. That's the chemical that I had to heat my cold hands up.
C2H5OH.
It's burned in the presence of oxygen, and it forms carbon dioxide and water gas. So I'm going to write C2H5OH. That's the ethanol.
Right.
That's stuff I had.
It's burned in the presence of oxygen. Now oxygen's O, right?
Sort of. Mr. Brinkelhoff,
All right. That's the
the
ah.
magic 7.
It's the ah in Brinkelhoff.
Off. Oh, okay, that's O.
Right.
But it's
Diatomic.
atomic.
So it's O2.
So I do not write O, I write O2.
Yep.
And then we draw an arrow. What does that arrow mean?
That means reacts to form.
To make. So it's like an equal sign, sort of, yeah? But it turns into carbon dioxide. Well, this is a molecular compound,
Yep.
the carbon and
So use
oxygen.
the prefix system.
And yeah, so this is the Greek method, so it's
Yep.
just CO2 plus water gas,
H2O.
H2O. Now, one thing we should talk about here is there's something called the states of matter.
Yeah.
Now, the ethanol, what state of matter was that?
That was a liquid.
So I'm going to put a little L right there in parentheses and subscripted. Okay?
Okay.
Now oxygen, well, oxygen I know
That's
is
gas.
it's a gas because I breathe it all the time.
Yeah.
So that's a G. And then carbon dioxide was a G.
That's a gas.
And water was a G. So
Right.
it's G, all the liquids plus a bunch of G's. Now, by the way, what would be the symbol if I had a solid? I don't have a solid in this
Little
particular example.
S.
It'd be a little S with the parentheses.
Yeah.
So S equals solid.
Uh-huh.
L equals liquid, and G, parentheses, equals gas. Now there's one other we should also talk about, and that is we have a lot of things that happen in a solution.
Dissolved in
And
water.
they're usually dissolved in water, and the symbol for that is AQ. AQ means aqueous. Aqueous.
Like aqua, water.
Yeah. All right. I'm an aquatic person. I love to swim. That comes from the word water, aqua. I think it's Greek or Latin or something. I don't know. Whatever.
Sounds
think?
Greek.
I think it sounds okay. Greek. I could go with Greek. Okay. All right. So let's just do a couple more examples. Okay. So our second example: solid calcium carbonate.
Actually,
Is-
no, I lied. I think it might be Latin.
You think so?
Yeah.
Oh, okay. All right. Solid calcium carbonate is heated and turns into solid calcium oxide and carbon dioxide.
All right, solid calcium carbonate. All right, calcium carbonate. Calcium is Ca, carbonate is CO3.
All right, before we do that, I think we need to figure out what the formula of this, because this
Yep.
is an ionic compound.
It is.
And we have to sort of play the Roman
charge
numeral
game.
charge game.
No Roman
Calcium is Ca. Now, there is no Roman numeral. Why not?
Because calcium is not a transition metal.
So I have to play I just look at the periodic table.
Yep.
And so if I look at the periodic table, here is calcium right here. And calcium is is +2. Okay, so if it's +2, because he's in the column +2, that's how
Uh-huh.
we figure that out. So I'm going to write +2 right here. And then carbonate. Now, how would you find what is carbonate?
That's a polyatomic ion.
So where would I find that?
On your polyatomic ion list.
Yeah, so that's CO3. We have it memorized, -2. Now, do the charges add up to 0, Mr. Sanders?
They certainly do.
Well, this is an easy one, man.
Yeah.
CaCO3 solid.
Because it said so.
And
Solid.
it's heated and turns into. I'm going to
turns
write
into
an arrow.
arrow.
And actually, we should add something. When you heat something, there's a little things that you put down below here. This is this little triangle. It
It
means
goes above the arrow, doesn't it?
I don't think it matters.
Oh, okay.
Heated.
Somewhere near the arrow.
Yeah.
All right.
Can go above or below. I don't think it matters.
All right.
If you want to put it above, knock yourself out. Yeah, I think maybe you're right. Probably more convention, but I don't think it matters.
Yeah.
All right, that means it's heated, and it turns into solid calcium oxide. Oh, I got to play that game
We got to
again.
do the charge game again.
So the
We
charge
have
of calcium is
that's
+2,
there.
and then oxide.
Yeah.
That'd be O2, right?
Yeah, no,
Why not?
because oxygen.
But it's oxygen. We
No.
just learned it was 2.
Oxide is in a compound. It's an ion in a compound.
All right, folks, that's very important to understand. Is this just going to be O with a charge? Do not. Its charge is -2, because if you look on the periodic table, I'm not going to flip there, but it's in the column that's -2. So this is easy. I'm put calcium with oxide.
CaO.
Charges canceled. This one's easy schmeezy, Mr. Sam.
It is.
And it's a solid. It says it's a solid, right? It says solid calcium
Right there.
oxide.
Yep.
And I would know that. Well, we'll talk about that later. And carbon dioxide, CO2. And that's a gas.
Yes.
And we're done.
the end.
Now, by the way, there is something about balancing reactions, which we're not balancing these reactions, folks. That's going to come in our second podcast. And so even though this one actually is balanced, we may have ones that are unbalanced. And you might say, where'd the extra O's go? We'll show you in the next podcast. Okay? I think we've got one more example.
I think you're right.
Example number 3, aqueous silver nitrate. Ooh, there's that aqueous thing we talked about.
Yeah.
Silver nitrate. Okay. So, silver.
Yep.
Ag.
That has a +1 charge.
Now that's a weird one. It is a transition metal, but it's one of the
Yeah.
exceptions to the transition metal, sort of the exceptions to the exception, so it's always positive one.
Yeah.
And then nitrate
But
from
it
the
probably wouldn't be wrong if they put silver Roman numeral 1.
No, that'd be fine.
Yeah, that'd be okay.
Yeah, okay, and nitrate has a charge of minus one.
Hey,
I got
that's
that from
easy.
your periodic table.
+1 -1, that adds up to 0.
Yeah, so that'd be Ag NO3.
Aqueous.
And I'll put a little AQ. Reacts with aqueous sodium chromate.
Okay.
All right,
This
sodium
one's not
is
gonna add up to 0.
Na, and his charge is positive
+1. Yep.
And then chromate is from the back of your periodic table, CrO4 -2, so, or your whatever your polyion list is. Those charges don't add up to 0, Mr. Sims.
No, they don't.
So that's going to be...
We need 2 sodiums.
Yeah, so guys, we've done this before, but it's just good review. Na2 CrO4.
Aqueous.
Yeah, and that's going to be an AQ here. And it makes solid silver chromate. All right, so I'm going to put the silver with the chromate. Those don't add up to 0 either,
No.
Mr. Sims. But I need two.
Ag2 CrO4.
The reason, of course, is you need to have 2
And it's a
positives.
solid.
And that's a solid. And then we're going to make aqueous sodium nitrate. That's these two guys put together. So that'll be in. They do add up to 0.
Yes, they do.
Now, folks, one thing I want to say here is I like to have, I sometimes call this section right here my scratch pad, where I write out the ions with their charges, and then I figure out what their formulas are.
Yeah.
So this is the answer. We have now converted this to a chemical equation in the formulaic sense from words.
There it is.
Okay, pretty easy.
Yep.
All right. Now, let's talk a few minutes
matter.
about the states of matter, okay? This last set of problems, it talked about the states of matter, and I told you what they are, but there's actually a way to predict what the states of matter. It depends on the type of substance they are. So let's take a look at one substance. First of all the examples we want to talk about, we will assume that they are at room temperature. Anything can be turned into a liquid or a gas
If you get it hot enough.
if you get it hot enough.
Yeah.
All right, so let's assume at room temperature what states of matter are these. Okay. First of all, let's talk about ionic compounds. You know, I think we ought to just watch a quick video.
Let's do that.
I think that's probably easier. So let's watch a quick video on ionic. So how do you know what the state of matter is of an ionic compound? Now remember, an ionic compound is a bond between a metal and a nonmetal. Well, I happen to have some here. If you look down here, sodium hydrogen carbonate, NaHCO3, metal to nonmetals. Looks like it's a solid. If we move over here to ammonium chloride, it's sort of it's a cation to an anion. That's still ionic. Guess what? That'd be a solid. If we run over here to copper chloride, oh, nice pretty blue stuff, right? Metal to nonmetal. Oh, that would be a solid. Yeah, and we go to calcium chloride, that's a metal to nonmetal. Looks like it's a solid.
Look, it's a solid.
Guess what, guys? And we go to sodium chloride, solid. We go to aluminum sulfate, solid. Guess what? Most ionic compounds at room temperature are solids. In fact, all, not most, all of them are. Ionic compounds. So, Mr. Sams, what state of matter are ionic compounds?
Solid.
Okay. Ionic equals solid. All right, I'm good.
Okay.
All right, let's take another one. Let's talk about
At room temperature.
at room temperature a
Covalent
compound.
Okay.
Hey,
Perhaps we should watch another video.
video time! How do you know if a molecular compound, a covalently bonded compound, what state of matter is it? Okay, well, I happen to have a container filled with water. Notice water is a liquid at a room temperature. Now, not all covalent compounds are liquids, but I have another example over here. If we jump over here, I have hydrogen peroxide, also a clear liquid. Now, they're not all liquids. Some of them are solids. Actually, here's kind of the general rule of thumb. The higher the molar mass, remember we learned about that in the last unit, the higher the molar mass, the more likely it is to be a solid. The lower the molar mass, the more likely it would be to be a gas, and in between would be a liquid. So, for example, I'm exhaling carbon. Oh, about blew Mr. Sam's way. Okay, I brushed my teeth. Carbon dioxide. Carbon dioxide, CO2. Carbon and oxygen are both nonmetals, and that's a gas. But CO2 only has a molar mass of 44, so relatively low. If I take something like sulfur, which is actually S8, its molar mass is 32 times 8, and sulfur is actually a solid. So it depends. So it sort of depends with your molecular compounds. There's no hard and fast rule like with ionic compounds. All right. So what state of matter are covalent compounds?
It depends.
Yeah, this is the depends one. Yeah.
Yeah.
So yeah, hard to say. If it's yeah. All right, let's do one more.
Okay.
What about just elements by themselves?
Elements. You know what I think we should do?
What do you think?
Watch another video!
All right. Hey, now I want to talk about is how do you know what is the state of matter of elements? So for example, I happen to have a bunch of pennies in my hands. Well, they're solids. Well, pennies are made of copper. Well, copper is an element on the periodic table. So if you go over here to copper, you'll notice, well, on our periodic tables in our room, the copper is actually colored black. So guess what? Black stands for solid. Okay, but not all elements are solids. Some are liquids and some are gases. Turns out there's actually only 2 elements that are liquids
At room temp.
at room temperature. Actually, we're only talking about assuming at room temperatures. And the 2 are mercury, and notice it's colored blue on this periodic table, and then bromine, and it's colored blue as well. And of course, gases, guess what? They're colored red. So if you look over at the periodic table, most of the, you've got helium, neon, all the noble gases are gases, of course. And then nitrogen, oxygen, fluorine, chlorine, etc. are also red. There's one other one you should also talk about. Of course, hydrogen is a gas. Okay?
A video.
So, elements, what do you do?
You look at the periodic table?
Yeah, just look at the periodic table. Bromine and mercury are your liquids, and then there's a few gases, and most things are solids.
Yeah.
Well, guys, I think that's like it. We're finished with 4.1.
Yeah.
You understand the reactions? We warmed our hands on the very, very cool ethanol. It's very, very warm. And now I'm hot. Okay. Well, we will see you in class or on the internet.